right, so how many for 1.1, number 1? Put up 1 finger for A, 2 fingers for B, 3 fingers for C, 4 fingers for E. Okay, 4 fingers for D, 5 fingers for E. Sorry. So to get a 1, 2, 3, 4, 5. All right, fantastic. So question number 1, problem number 1, the correct answer was E. And 93% of students got that correct on a AP exam from the past. So congratulations, you have now gotten 1 out of 5. So your goal on these 5 for 5 questions that we're talking about is to get 3 of the 5 correct. If you get 3 of the 5 multiple choice questions correct, then on average you are passing the AP exam. So the idea is to get 3 of the 5 correct. Number 2, give me a 1, 2, 3, 4, or 5. Okay, so we're kind of mixed on this one. We have a couple different answers. So let's go over that. I'm going to put on my video. Let's see if I can change it. Well, it's currently spotlighted on the classroom. Okay, so the correct answer is actually D. The correct answer is actually D. So does anybody need to see number 2 now that you know the correct answer? Because again, all of us, okay. So we were kind of all over the place. So we have the integral from 0 to 4 pi fourths of sine x dx. So the antiderivative of sine is negative cosine. So if you think about the derivative of cosine, it's negative sine. So the antiderivative of sine is negative cosine x from pi fourths to 0. So it would be negative square root of 2 over 2 minus a negative cosine of 0, which would be a negative 1. So you get a negative root 2 over 2 minus a minus 1, which turned to a positive, which gave me answer choice D. Now, this one, 58% of students got this question correct. So you can see this one was definitely a harder question than question number 1. So 93% got question 1, 58% got question 2. All right, number 3. Give me a 1, 2, 3, or 4, or 5. You'll be happy to know too, your odds, good. Your odds have gone up. So your odds have gone up. They went from having 5 multiple choice options down to 4. So previously you had a 20% chance of getting a question right based on guessing. Taking it from 5 to 4 gives you a 25% chance on guessing. So you have a higher chance of guessing. I also think though that when they went from 5 to 4, sometimes the questions got a little bit more difficult. Number 3, your correct answer is B. And number 3, the correct answer was B. So you should have held up 2 fingers, which again, I think a good majority of us had up 2.
Would the following students please report to the office? Hannah Ritchie, Alex Sage, and Matt Rager.
Okay, number 4. So 1, 2, and 3, those percents are always over 50%. 4 and 5 are the more challenging of the two questions, and 5 is usually the toughest when I give you the factor of 5s like this. That's the way that Brian Passwater kind of created them, to make 1 through 3 super easy, 4 and 5 a little bit more challenging. So 4, what do we get? All right, good, 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 good. So again, in our room, I think we're a little bit higher than the normal average. 44% picked the correct answer, which was A. Is anybody? And again, as we... Yes. Okay, so F prime is 1 over, so this is a natural log. The derivative of natural log is 1 over the inside of the natural log times the derivative of the natural log. So F prime of x would be 1 over x plus 4 plus e to the negative 3x times the derivative of all of that. Derivative of x is 1. Derivative of 4 is 0. And derivative of e to the negative 3x is e to the negative 3x times negative 3. And then what we had to do is plug in a 0 for all of our x's. So you got e to the 0, which is 1. So you got 1 plus negative 3, which was negative 2. And then 0 plus 4 is 4. 4 plus 1 is 5. Okay? So again, the more multiple choice you see that's similar to that of the AP exam, the better you're going to do in whatever that is, like a week and a half for those multiple choice questions. The multiple choice on the AP test is all about strategy. Can you figure out the correct answer, knowing the techniques you need to know? All right, number 5. So there are about 15 of us in here. 22% of students got this correct when it was given on their AP exam. So my hope would be that 3 of us get this correct. If 3 or more get it correct, then we beat the class or national average. So number 5. 1, 2, 3, 4, or 5. Okay. Can't see Zach. Okay. All right, so we are tied with our national average. Correct answer is E. All right, boys. Do you know how you got E? Or was that just a very lucky guess? So is that your logic, that they were both increasing, therefore speeding up? All right. So number 5, it does say that it's twice differentiable. It's positive on the derivative and positive on the second derivative. So that's not a bad thought. It does tell me it's increasing. That also tells me it's concave up. It says for all real numbers x, such that g of 4 is equal to 12 and g of 5 is equal to 18. Of which of the following is it possible for g of 6? So again, I would kind of be like, okay, 1, 2, 3, 4, 5, 6. Almost like you said, 4 is at 12. 5 is at 18. So automatically it couldn't be 15 or 18. So if you had A or B, those did not work because they were less than or equal to the numbers we were already given. And if it's increasing and concave up, we knew for certain it had to be greater than that. So then how do you determine between C, D, and E? So again, the idea is concavity. If this is increasing at an exponential rate, if you pick 21, then that was not increasing. It actually would have shown a little bit of a decrease in terms of the slope. Because this went up by 6, your answer had to go up by 6 or more in order to be concave up. Sorry, I actually drew that concave down. Does that make sense? So it needed to go up. Sorry, I was drawing. Because it would be equal to 6. And if you think about, so since this increases by 6, then 18 plus 6 is 24. So that would make it linear, not concave up. So if it went like that, it would have been linear. And this needs to have concavity, so it needed to increase even more. Does that make sense? It's all about the slope, which is derivative. So the slope needed to be greater than the slope before it to be concave up. Okay, let's see how we do on part 2. Okay, number 1. We get A, B, C, D, or E. Okay, good. Good, 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 good. Excellent. Correct answer is D. 83% of students got that one correct. I think we were even higher than that. Number 2, A, B, C, or D, or E. Good. Good. Okay. Correct answer. We were kind of a mixed bag of answers, to be honest. Correct answer was C. This is a horizontal asymptote. So since you're looking at x going to infinity, so we look at the exponents and say they're the same. Therefore, it's the coefficient of the terms. So, L'Hopital's would have given you 3/12, which still would have reduced to 1/4. Oh, okay. I thought you were saying you did it and got like the wrong answer. Okay, number 3. Okay. Number 3 is actually harder than number 4 according to the national averages. Number 3 was D. %45 of students got that correct. Do we need to see number 3? Yeah. Okay. So this is an integral. I would treat it like a u sub. So I would say u equals -4x. So my du equals -4 dx, which means I need to make it 1/4 du equals dx. So I would change that so it was -1/4, 0 to 1, e to the u du. And then we know that the antiderivative of e to the u is e to the u. So it would be -1/4 e to the u from 1 to 0. But I can't plug in my 1 and 0 right now unless I either change the 1 and 0 to meet the values of u, or I have to plug my x's back in because these bounds are with respect to x right now. So I'm either going to plug into -1/4 e to the -4x with 1 and 0, or I had to change my bounds. But if you leave it as is, you get negative 1/4 e to the negative 4 minus a minus, which is a positive 1/4 e to the 0. And we know anything to the 0 power is 1. So therefore you have the 1/4 minus 1/4 e to the negative 4. Again, this question was from 2003. Since 2003, they have eliminated their answer choices having negative exponents. Okay, number 4. Number 4 was actually had a higher percent of correctness than number 3. So what do we get? Good, good. Good, 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 good. So we're almost at that higher percent rate as well. Number 4, correct answer is B. Correct answer is B. So that is kind of an implicit differentiation. So you would have to take the derivative of each of those. So you had 6y dy dx minus 4x equals 0. And then you had to remember that that was a product rule. So it was the first times derivative of the second plus the second times derivative of the first. And then at this point, I would have just plugged in all of my x's and y's. So y was 2, 6 times 2 is 12, dy dx. 4 times 3 is negative 12. And then you have 2 times 3, which is 6. So you have negative 6 dy dx. Plus 2 times 2, which is 4, but then the negative distributed. And then I get my dy dx on one side and the numbers on the other. So you'd add 12, which gave you 8. And then you'd add your 6, so you add your 18. dy dx, divide both sides, and that's how you got 4/9. You'd have 8 over 18, which reduces to 4 over 9. My hopes for 5 are that since we went through this technique and we kind of learned a formula, we're good. But if not, back then, the percent correct was 18. So let's see if we can beat that, which means I just need 2 of you to get number 5 correct. So what do we get for 5? Okay. And we've already beaten the percent. Good, 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 good. Okay, we blow their percent away. Correct answer is B. So again, it says if g of x equals f inverse x and g of 2 equals 1, what is the value of g prime of 2? So that's that idea where you had to just take g prime or g inverse, which was really like f inverse, and find 1 over f prime of the x value. So you would have found the derivative of f of x and then put 1 over f prime of x, and you're plugging in the x value. So I might need to see it, or are we okay? Okay. So what I'm going to do is take a pause here. We're not going to do 1, 3, 4, 5. We're going to save those for tomorrow. You can take your 4-minute break, and then when you come back, we're going to talk and briefly review limits, and then that'll be your homework review for tonight. And I did want to go over the answers to the circuit from last night, but I don't think I had you submit that yet, did I? It was due this morning. Okay, perfect. Then we can go over it. Yeah. Okay, go ahead and take your 4-minute break. I'll see you back here at 33. Alright, so at the beginning of class today, I gave you a handout, and it said AP Calculus, stuff you must know cold. And I'm not really doing much with you with this, but this is essentially the AP exam in a nutshell in terms of what you need to know or should know for formulas. So there's a curve sketching analysis, there's your basic derivatives, your inverse trig derivatives. It has like a nice brief summary of fundamental theorem. It has a nice brief summary of IVT, MVT, and rules. It goes through the differences between distance, velocity, and acceleration. Now, what you can kind of think of that we're not really doing is the disk method. And then average value. Average value is just a normal integral, but you have average in front. So the two big things kids mess up a lot is wording. So you have average value and average rate of change. Average value is an integral. Average velocity or average rate of change goes with the slope. So average velocity or average, if you want to add it in, so you have that wording on there. This is also average rate of change. Average value is an integral. So then we have left, right, and trap. And then on the back page, this is almost more helpful in terms of things we used to do. So you have L'Hopital's. You do not have to worry about integration by parts. That was a CHS and or BC topic now. So you can actually eliminate integration by parts. This is just helpful for having all your trig stuff. And then down at the bottom, that's our CE stuff that you guys don't like very much. And then there's your inverse derivative that we just had the question number 5 about. Okay? So if you do nothing else outside of class to study, study this. So yesterday I had you guys doing this calculator cycle where you were using your graphic calculator to get answers. These are the correct answers. And then if you need to see work for them, we can go through and do work. So you should have had negative 0.151 for this, 14.137 here, 170.306 there, negative 3.623 here. Oh, I forgot. This one was a big one, and if you couldn't get this answer, make sure that you took the derivative of 4. So this is a fundamental theorem of calc question, and in order to get the correct answer, you had to remember that when your bound is something other than an x, you have to take the derivative of it and multiply it by your antiderivative plugged in. And here we got 0.210. Oh, you're good. And I'll slide that in for you for 1 second. Here's kind of like the formula and how you got the answer and the drawing. Just because I know that one was a little difficult. Because the graph right here, x equals the square root of y minus 2. If you plug in, because it said x equals 0, if you plug in x equals 0, you get the square root of 0. I plugged 0 in for what? you get 0 equals the square root of y minus 2. So then you work backwards and solve for y. So I squared both sides. And I got y minus 2, so I added it. So what I found was that the starting point of my graph was at 0, 2. So since I was integrating with respect to y, my y value needed to be 2. Okay? And then on the second page, top answers go 4 and negative 0.148. And then 12.25 and 22.3. So again, this gives you a rate. So to find gallons, you had to integrate. You integrate a rate. And then we had 2.6 repeating and 4.737. Do you need to see any other ones besides the one I already showed you? So again, these ones are all primarily on your graphing calculator. These questions would either come from the calculator FRQ or the calculator free response. So like I said, our goal for today was limits and continuity. We started the day with the quizzes. That was a team limits and continuity activity. We're going to go over a limit and continuity review handout, and then there are some limits and continuity practice. So I'll put a Dropbox for this on. You're welcome. Yes. You're welcome. I didn't want you to do a crinkly one. So that I put that data on top just for everybody else, so I didn't want you to be off. It was just crinkle. Alright, if anybody needs their staple, here's a stapler. Alright, so limits and continuity. Limits and continuity are a huge part of calculus. It's where we began our study of calculus. So, there we go. There are a couple things you need to know in terms of limits and continuity. The limit of a problem is going to give you an idea of whether or not it is continuous. So there is the existence of a limit at a point. This is essentially the definition of continuity. So in order for a function to be continuous, the limit has to exist. So this right here is this part of the continuity definition. If you are asked to use the definition of continuity to either prove why or why not, you have to use one of these three statements. Say function f of x has a limit. The limit only exists if the left-hand limit equals the right-hand limit. It is only continuous if there are no holes, jumps, or vertical asymptotes. So right here it even says, when answering free response questions in the AP exam, the formal definition of continuity is required. This statement right here is the formal definition of continuity. So like that first page I gave you today is this page right here. So again, I'm saying like things to study. This is something I would read or study that night before. I would make sure I know the formal definition of continuity. Going back and thinking about the definition of the derivative, a derivative is a rate of change. A derivative is a rate of change. The definition of the derivative is essentially the slope formula. You're looking at the slope of f of x plus h minus f of x all over h, trying to make that h value as small as possible to find that instant slope. Continuity and differentiability. Differentiability implies continuity, but not vice versa. Differentiability implies continuity, but not vice versa. You can have a continuous function that is not differentiable. Case in point, absolute value. Absolute value functions are continuous, but not differentiable at all points because they have a corner. However, if you are told a function is differentiable, then you know it is continuous. It's like knowing all squares are rectangles, but not all rectangles are squares. All differentiable functions are continuous, but not all continuous functions are differentiable. L'Hopital's gets thrown into our limits and continuity review. You don't have this page because we've just reinforced L'Hopital's. It's at the top of that AP stuff called To Know Turkey handout. Turkey, whatever, can't speak. Need to know cold turkey, turkey cold. I guess you could eat cold turkey. Given that f and g are differentiable, then you need to either get the indeterminate form to be able to apply L'Hopital's. So what I want to do before I release you off into doing a couple of these alone is just to look at this question here together, because this question we actually already did, but we didn't have you don't have this, you don't have this. I'm just talking you through it real quick. You don't have it. The back of the first page is blank if you want to write it down, though. So like your reference page, the back of it's blank in case you want to write it down. So it says, consider the differential equation given. See, because I wasn't technically allowed to photocopy this one because it was from an AP exam that's not released. Let y equal g of x be the particular solution to the differential equation g of negative 1 equals 2. Find that limit. So what happens is, as you take negative 1 and plug it in for g, this becomes 2. So you get 2 minus 2, which is 0. So I get a 0 on top. And then if I plug in negative 1 down below, I get negative 1 plus 1, which is 0. So I get a 0 on bottom. So this becomes a L'Hopital's because you get a 0 on top and a 0 on bottom. So in order to do this as a L'Hopital's on a free response question, they got kind of goofy with their rules. Okay. You have to show the top equals 0. You have to show the bottom equals 0. And then you say by L'Hopital's. So if this was an FRQ, you have to actually do it a little different than we did in the past. Remember, it's derivative of the top, entirely separate from the bottom. It's not a quotient rule. So if you go back here, we were told dy dx is equal to g of x, so that means this is also g prime of x. So to know what g prime of negative 1 is, I'm actually using that right there. So what you'll notice is that even after we take the derivative once, we end up getting 0 over 0 again. So you take your limit, plug it in. So x was negative 1, y was 2. So you actually L'Hopital this one twice. So it's kind of like 6x plus 6. So you just get 6. And the derivative here of that x squared minus 1/2 y would be 2x minus 1/2 dy dx, which is actually that problem. Which we already said this answer is 0 from the previous time. So you'd get 2 times negative 1 over 6, which is negative 1/3. So that is like the most difficult L'Hopitals you will get. You can use, well, there's only about 10 minutes. The remaining class time, the packet is multiple choice. It should take you no more than a half an hour. So go ahead and just do the multiple choice in that packet, because again, it's 2 minutes per multiple choice. Do not worry about 20 and 21, which are the FRQs. We'll do those together tomorrow. So you're doing the multiple choice. There might be a few more than 15. Might be or 19. So a little more than half an hour, sorry. But some of them are easy. Some of them will take you about 30 seconds. Yeah, I just opened it up while we were on our break. What? Sorry, your APA test is May 4th. There's no